Welcome to Data Skeptic K-means clustering, the podcast exploring the problem, the algorithms, enhancements, and use cases for K-means clustering. Welcome back to the show, Linda.
Hello.
I wanted to have you on to talk about a specific use case for our topic this season. And I sent you some images in preparation for this. Not the owl I sent you yesterday or the chickens before that. Scroll back in Slack till you get to the parrot pictures I sent you, the ones of Yoshi. Can you describe what I sent you, this being an audio podcast, us referring to an image?
Yeah, Kyle sent me the same photo of Yoshi sitting on a perch. She looks pretty happy, but there's 4 images, so there's one in each quadrant. And they all have a different effect on them. So it's kind of like Andy Warhol, but not really at all.
Good example. Yeah, I think that gives a nice comparison. Would you at all compare this to your Instagram filters?
These are a little bit more extreme than Instagram, because Instagram somewhat tries to preserve what you look like, but here it's just kind of like you lose a lot of data in some of the filters.
Well, that's a good observation. That's exactly what's happening here. Do you have a guess about what I did to these images?
I mean, I don't know what you did, but some of the ones in the top left quadrant, they're the ones that most have the treatment. It just seems like you turned up the contrast way up. And then also it's like everything blends together, so only Yoshi's beak and her eyeball, but then she also blends into the background of the brick wall.
So at the end of this, I'm going to ask you for a new photo that might be better for this task, and that's probably the one that'll be the cover art for our show notes that listeners can check out. But I'll put the one with the brick background in the show notes as well for reference. But they might get a slightly different result. So let me tell you what I did here to these images. I took one original photo, obviously, of Yoshi on her perch with a little brick background in the old office. And then I applied K-means clustering to it, which is an algorithm. Now, we talked about K-means clustering, you and I, in a mini episode in 2016. So I'm sure that's top of mind for you, right?
I wish it were.
Well, and also we talked then about the more traditional way people do K-means, which is to put things that have a notion of location together. Like if you had a map with dots of where all the restaurants are, you might be able to say, well, the clusters of the restaurants are central business districts or shopping areas or things like that. But I took the same algorithm and applied it instead to this image. Well, how do I do that? An image, as you know, is made up of pixels that are RGB data, right?
Oh, yeah.
And actually, I don't know if you'll know this. You can tell where I stopped being interested in computer graphics, but I think the ranges go from 0 to 255. Is that right?
I don't know. That's a good question.
But whatever it is, even if they have much higher resolution stuff now, there's a finite number of colors in any image.
Oh, yeah. Well, if you're looking on your computer screen, yes.
Well, yeah, if it's a finite-sized image, it must have a finite number of colors. And the max it could have is where every pixel is a different color, but that's probably not an interesting photo.
Yeah, rainbow.
Yeah. So I didn't actually get the count of the number of distinct colors. Maybe I could have gotten that if I thought that was important. But I converted every pixel into a data point that has R, G, and B. It's how much intensity of each of those colors. And then what I asked K-means clustering to do was to group all of those colors into, however many groups. So in the upper left, it's K equal to 2. So the problem essentially that I asked the algorithm is to decide how to recolor this image with only 2 colors that's most faithful. Now you have a background in photography. Would you say that artistically I accomplished that?
Yeah, I mean there's 2 colors, kind of a whitish and a blackish. So between that, Kyle makes use of positive and negative space.
Oh, that's funny that you describe it as a whitish and a blackish, because that makes total sense to me. Because when you think about it, there's a range of colors in that image, right? I'm not saying that every color in the world showed up, but it's not like a picture of the Japanese flag where there's 2 colors. It's a real-world picture. And so if we think ahead to clustering all of the colors across the whole spectrum. So the clusters need to be far enough apart to be interesting. So one, if you only allow 2 clusters, one has to be close to 0 and one has to be close to 1, which is black and white in the way we process images. So it's kind of intuitive that you would find that result.
Yeah, I mean, it's basically a black and white image with no grayscale, really.
Exactly. It's a 2-color image, no grayscale. So now move one to the right. So I sent you 2 images. The earlier one is subtle, where it's k equal 2, 3, 4, 5, and the second one is k equal 2, 4, 6, 8, just to show a little bit more development. Look at the second one, I think. So if you look at the upper right on the second image, that's now k equal to 4. So same idea, but I said in this case, recreate the image with 4 colors as faithfully as you can. And what's changed to your eyes?
Well, now you can see Yoshi in a little bit more variety of colors and nuance. She stands out from the brick background, and you could actually see the feathers in her little cute chest and her little feet.
Mm-hmm. You notice anything about her stand or some of the other features?
Well, I mean, also similarly, that you're distinguishing the foreground from the background, so you can see her stand, and it doesn't blend as much into the background.
Oh, that's true. I actually meant it in a different way. You're right, because there are more colors now. There's a little bit more diversity because we can be more expressive.
Well, let's hear it. What do you think?
My observation, and it's in line with what you said earlier, information is erased. The stand now, the wooden parts, are like basically one color. There's some shadows that are a different color. But what this tells me is that the wood grain, the variance I see in real life, where I can tell, that it's not just a homogeneous, material, like an artificial thing, that it's an actual heterogeneous material of wood, but you lose all the wood grain and texture information because there isn't a lot of difference there. It's very subtle compared to the difference between the red bricks and this tan poplar color of wood that's on her stand. So the algorithm didn't even try to, quote unquote, recognize the wood. It just said, oh, this is all so similar, we're going to lump it together.
Yeah, I mean, I don't have access to the original image, so, I don't know how much information was lost or gained. I'm just going off of the black and white one in comparison.
Oh, fair point. Yeah. But you know that stand. You know what it looks like.
Yeah, but it's another thing to have the image side by side to compare.
That's true. Maybe I should send you that as well. And then let's go to the lower left, where now it's k equal to 6 colors. Any observations about improvements in the quality or artistic merits of this image?
Well, I mean, it keeps just getting more granular, Like Yoshi, she has a little bit of red and lilac and a little bit of green in her head, and it's just popping a little bit more by this third image.
Yeah, in real life, she's a lilac-crowned Amazon, right? What are her most noteworthy colors?
Her number one color is green.
Mm-hmm. But she's got more than green going on.
She's a green parrot, but then her next noticeable is she has red on her head, and then she has lilac, and then a few different colors of green, kind of like a helmet, forming a helmet head.
Yeah. So I feel like for it to be faithful, you got to get green, red, and lilac.
Yeah.
Which, now the algorithm, when it picks the colors, it doesn't know anything about lilac-crowned Amazons. It doesn't even know this is a bird in the image or that the bird's important to us. It could have focused on other things, like the brick wall, which, doesn't have a lot of features to it. So it's kind of interesting that the parts we find important are being highlighted, although that's not always for sure. What do you notice now as we look at all 4? How long does it take from k equal 2, 4, 6, 8 for Yoshi to kind of come into focus?
Which one's 2, 4, 8, 6 that you were talking about?
Upper left is 2 colors, to the right is 4, next row 6, and then 8.
Yeah, I mean, you could tell Yoshi by the second image for sure. If you didn't know what a bird was, you could definitely. If you're still confused, definitely by the third image.
That's true. Although look at that fourth image where now we have 8 colors. Can you describe what our bird on her stand in the old office looks like when only 8 colors are used?
Yeah, I mean, she looks the same, except now they painted Yoshi mostly green. And then the brick wall is really a brick color, and then her stand really is a peachy color. But the peach did start coming in at image 3.
Yeah, our colors are coming into focus, but Yoshi looks incomplete to me, It's like they just, like a rushed comic book artist, instead of doing any detail or design, they just kind of paint bucketed a solid color.
Yeah. They don't know how to treat. I mean, when you only have 8 colors, you got to round to the color that you think is closest, and then you got to simplify.
Now, if you had handpicked 8 colors, do you think you could have done a better job?
Yes, for sure.
Okay, how come?
Well, overall, these colors are very muted, so I'm not really sure where this tone and mood came from. But yeah, I would have just picked brighter colors that are more saturated and brighter, less muddy. These are kind of muddy colors.
Thanks to our annual sponsor, Weights and Biases, the developer-first ML platform. Weights and Biases is an enterprise-grade platform that gives you experiment tracking, dataset versioning, and model management. Their solution integrates with TensorFlow, sklearn, XGBoost, Hugging Face, and literally every other framework I could think of. Integrating with your model training process takes just a few lines of code. And there's even a nice live notebook on their site that'll show you how to get it going. Once your machine learning code base or notebook is wired up, you've just unlocked the next level of productivity. The Weights and Biases platform collects, aggregates, and beautifully displays all of your key metrics and telemetry so you can track your model training in real time and compare different runs. Have you ever had to screenshot a matplotlib graph that you drop in an email or in Slack to show your boss the results of your work? That's like serving a gourmet dinner in a cardboard box. With Weights and Biases, all of your collaborators can see the results of different runs with an idealized interactive suite of tools. You no longer have to be the single source of truth for your whole organization about how the model's doing. If you're on or leading a growing team of machine learning practitioners, you need to investigate if Weights and Biases is the right solution for you. Get started at wandb.me/dataskeptic and mention us when you request a demo. Thanks to our sponsor, Nomad Data. They help you find better data faster. There are many data science projects where you need some external data, and that's never an easy step in the process. The search for the right data can be long and arduous. There's a lot of noise and snake oil, too, but there are great data providers out there if you can connect with them. And that's what Nomad Data helps with. You tell them what you're looking for by describing your use case in detail. You give a few more parameters like the sector, and you can keep your identity hidden if you want. Nomad has relationships with hundreds of data providers, and they also have the technology to match your requests to the most qualified ones. Those providers evaluate and respond to your needs. Each seller takes a good look to see if they actually are a fit for you. Nomad brings you back all those responses and lets you select your data provider. Once you've done that, they'll put you in direct contact. If you have a decision to make and you need data to inform it, head over to nomad-data.com. Give them 10 minutes and let them show you how they can save weeks of time every year by searching for your datasets. nomad-data.com. All right, so let's dig into this. Maybe we can come up with our own approach, or probably what we need to define is a new loss function. Because this algorithm, it tries to solve an optimization problem, basically. We want to minimize the in-group difference. So pixels that we paint with one of our 8 colors, their original colors should be pretty consistent, which you can see in her feathers, right? Even though we've lost all the detail of her feathers, the difference by millimeter of the shade of green is pretty subtle. So in that regard, it's doing a nice job. The other factor is that the distances between groups need to be as far away as possible. And I think that might be what's getting us into trouble here, that the algorithm is trying very hard to create distinctive groups. Does that make sense?
It's trying very hard to make distinctive groups. Where do you get that conclusion from?
From knowing its underlying loss function. That one of the optimization criteria is that the centers of the groups themselves should be far apart. So like the algorithm is unlikely to pick 3 shades of green that are all very close together, which is what it would probably take to expressively describe all the pixels of her feathers, because algorithmically it looks at the points and says, hey, we have these 3 green clusters we're considering, but they're so close together, if we just merge those, the variance within the group gets a little bit bigger because, we're not as expressive about green, but by having only one shade of green, maybe we can start to also include the brick wall, or the color of that glass panel there, or the gray from her water bowl. So it kind of makes a compromise about where to deploy its limited colors by trying to have a broad coverage.
Yeah, I mean, that's a strategy anyone would take, right? If you only could pick 8 colors in the world, you try to have them cover the full range. So most likely they'll probably be spread relatively either equal distance from each other, the colors, or maybe they specifically select some colors being like, I know they're close and similar, but it's very important to get that information across.
Yeah, so therein lies, I guess, the difference between what I did here and the artistic level you were talking about. So if anybody wants to do a pull quote and have your name, this is a famous unsupervised learning algorithm. We could say muted colors and uninteresting by Linda Tran. What's your quote here?
I mean, it's just kind of muddy colors, so it's not representative. of real life. Was your red-green color filter on?
Well, thank you for disclosing my handicap of red-green color deficiency to the audience. Yes. Um, that's totally irrelevant here. This is all algorithmic work. I just apply the sklearn implementation of k-means to the image.
Well, I don't know. I wasn't sure how your image was exported.
Totally numerically. So you raise a good point. If I had used my biology in any way, I'm not equipped for this task, but luckily algorithms never fail.
Okay.
So, all right, do you think there's any worthwhile pursuit in trying to make this more in line with what an artist might choose for the colors?
I mean, I can't think of anything. If you're trying to ask me, is there anything profitable about this venture? I don't know.
Oh, this is less on profitability, but like, hey, maybe you and I could publish a paper on this, how we change the loss function of k-means to produce more suitable color reductions for artistic photos. That sounds like a good title, actually.
How to do it? I mean, I don't know how to do it, if that's the title of your paper.
Oh, I'll figure the math out. No. I'll figure out the loss function. What I need your help with is figuring out what we're minimizing for. Like I said, we're going to try and minimize the within-group variance. So pixels that share a color should be similar, and keep distance between the clusters, which partially explains why Yoshi got so muted.
But isn't that what they're already doing?
Well, yeah, that's how we got to this result. So if we wanted a better result, like here's my point. I bet if I asked you to custom pick your 8 colors, and then we did an A/B test on the listeners, like which of these do you think is more beautiful, they will pick yours over the k-means version. And I mean, it's an unfair test because k-means isn't optimizing for beauty. It's optimizing for centroids. But there is this sort of quality, like what is beauty? And you have some sense of it in the image. Maybe we could find a way to better cluster towards it.
Yeah, I mean, let me know what you need from me. Happy to help.
Well, I guess it's connecting on the math level. So I think we've identified one of the reasons why this photo is not necessarily artistic in the way it was compressed is because it fails to recognize where some of the details or importance are. Yoshi's the feature of this photo to me. You could blur out the whole background, and her feathers are critical to recognizing her. But the challenge is all her colors are pretty close together, which is why we almost lost her in that bush that one time.
Yeah, for those who don't know, when we put Yoshi in a bush and then you turn around and look back at her, it's hard to find her visually. She camouflages so well.
This is almost an unbelievable experience you have to have for yourself. Put her in a tree or a bush, turn around 360, you'll think you know where she is, and you do not.
Yeah, she's really good, kind of like a chameleon.
Well, I guess one of my main reasons I wanted to show this to you, first of all, it's always great finding algorithmic ways to chat about our parrot. But on top of that, k-means is so often talked about in terms of things that have, like I talked about earlier, some sort of location-based or geometrically distance factor to it. But it applies just as well to images that have their own dimensionality. So this is a fun way to kind of bring that idea of k-means into our season on this topic.
Well, I love it. Excited to hear what the audience thinks about these Yoshi photos.
So I think maybe now that I've told you a little bit about the algorithm, although perhaps you need to ask me a few more questions to help answer this next part, I was wondering if you could help me identify a better photo that we think would come out better by applying k-means clustering to it. Maybe if it comes out good enough, we make a t-shirt out of it.
Yeah, I could send over 1 or 2 photos and you could give it a try.
All right, so let's talk about the best quality photos by talking about what's not great. Like, I'm going to be honest with you, the photo we discussed today that'll be in the show notes with the brick background, I don't think I want to wear a t-shirt of that.
Nope, I do not.
No. So I don't want to put something in the store that's embarrassing. What's wrong with this photo that I don't want it on a t-shirt?
Well, you already mentioned the background just isn't very important, but the background takes up like 80% of the image.
Right. Now, if Yoshi was on a white background, or not like a perfectly lit green screen type of background, but even just like our dining room wall that's, all white if you take it from the right angle and there's no doors in it or whatever, that k-means would do the same thing to the white background it did to her feathers here. It would say, oh, there's not a lot of variance in the eggshell white painted walls or whatever color we have. So it would likely wash out the background, but that's okay, right? So I guess the lesson here is if we want to use k-means to feature a subject, we should have a very boring background so that the algorithm doesn't waste some of its centroids trying to describe the background. So there's criteria number 1. Yeah. The other thing is, it should include as much. Well, here's an impossible challenge. It would be best if it was equal parts green, lilac, and red. But that would be some weird close-up of her that wouldn't work out. Since green is the most popular color, as we increase the K, it would probably, well, actually, I don't know for sure. There'll be a little bit of bias just towards the commonality of some of the colors. So the more lilac and red we can get in the image, I think it'll turn out better. So something kind of close up, simple background, and let's try that. If it comes out cool, I'll announce a t-shirt in a couple of weeks. If it doesn't, they'll never hear about this again.
Great. Well, I'll send you some shortly.
Sweet. And then one last thing I wanted to ask you that's a bit of a pivot. A common, maybe the most common way I hear people talk about deploying K-means is for customer analysis, trying to find personas and groups of customers. That sounds, if not directly in your wheelhouse, at least adjacent to it from some of your professional experience. Have you ever dealt with data scientists doing K-means clustering?
I don't know. We definitely have done with personas and talked about where these customers are, what their lifestyles like, and developing those out. But I don't know if I've interacted directly with data scientists.
Okay. That might be for the best. I'm pretty skeptical about this application. Like personas, I'm already not thrilled with when they come from a marketing department. I feel like they're just kind of made up ideas. They don't necessarily correlate with the business. But a step towards addressing that is often to look at the data and say, can we cluster people? But it really, I think, takes a lot of feature engineering to meaningfully cluster people.
So what do you think we should do?
Well, I think if it's easy, this is just my off the top of my head advice about K-means clustering for personas and stuff. If it's an easy operation for you to do, a data scientist says, yeah, it's just an afternoon for me or whatever, then just go do it and see what the results are. Obviously, look at them critically and think about what sort of decision you want to inform based on those results. But ultimately, it has to be driving towards some core business decision. And if it's just analysis for analysis' sake, it's not going to help. But if you can meaningfully divide people into clusters and say, market to them differently, that could be valuable.
Great. Well, what should we do next then?
Well, I say you and I don't worry about that. We don't have too many marketing problems between us. At least not yet. Let's focus on this photo. And if it turns out great, we might have some marketing challenges around our Yoshi t-shirt.
Great. Well, hopefully there's a demand for Yoshi t-shirts.
We'll find out. I'm depending on you and the algorithm.
All right. Well, I won't let you down.
Well, thanks as always for joining me, Linda.
Thank you.
That concludes another installment of K-Means. Thanks to our sponsors today, Weights and Biases and Nomad Data. Myself, Claudia Armbruster, as associate producer, Vanessa Bly, guest coordinator, our show notes by David Abembe, and our host, Kyle Polich.